Welcome to the site, everyone. Look, if you're a fresh engineer, a civil engineering student, or maybe just stepping on to a real construction site for the very first time, you need to pay close attention right now. Today's explainer is, well, it's going to save you a lot of sleep, a lot of money, and maybe even save your entire career. I've been in this industry a long time, and if there's one single thing that separates a true professional site engineer from an amateur, it's exactly how they handle a concrete pour. You see, concrete pouring is the absolute heartbeat of our sites. But the moment that concrete sets, any mistake you made is quite literally carved in stone.
Let's dive into this. I want to tell you a real story about a massive, catastrophic failure I witnessed firsthand on a project. We're talking about a 50 cubic meter concrete pour. Think about that for a second. That is a massive amount of concrete. It's a huge coordination of manpower and obviously a massive financial investment from the client. And you know what? It was completely ruined. Not just slightly defective where we could patch it up, ruined. It had to be completely broken down and redone from scratch. The cost of the concrete itself, the wasted steel, the labor, the massive delay to the project timeline, it was just a total disaster. But honestly, the scariest part wasn't the cost. It was the fact that it didn't happen because of some unpredictable earthquake or a bad batch of cement from the factory. It happened because someone simply skipped the basics.
Let's trace exactly how this chronological cascade of failure actually played out. It all started innocently enough on day one. The engineer on duty was in a bit of a rush and decided to skip checking the latest approved structural drawing. Because of that single misstep on day two, the reinforcement was placed with entirely the wrong spacing and totally inadequate cover. The engineer just kind of glanced at it, gave a quick thumbs up, and moved on. Day three rolls around. The RMC trucks arrive, the concrete pour happens, and everyone goes home patting themselves on the back for a hard day's work. Then comes day four. They remove the shuttering and absolute nightmare. They discover severe honeycombing, the concrete hadn't settled properly, the rebar was completely exposed, and structural integrity was practically zero. So by day five, we were bringing in heavy jackhammers for a totally costly and, frankly, embarrassing demolition.
You really have to ask yourself, how does this happen? How did a totally routine pour turn into such a massive project disaster? How did we go from just another standard day at the site to a full-blown crisis with extreme client dissatisfaction, huge financial losses, and major safety risks? The answer is incredibly simple, and it's a trap I see junior engineers fall into all the time.
The failure happened because the engineer relied on what I like to call the lazy method, visual checking only. You know how it is, you walk past the formwork, you look at the steel, it looks generally fine to your eyes, and you just say, oh yeah, pour the concrete. No, absolutely not. Visual checking directly leads to loose shuttering joints, slurry leaking all over the place, improper cover, rework, delay, and crazy extra costs. The only real way to ensure structural quality, maintain site safety, and actually guarantee client approval is by rigidly following a proper checklist process.
Let's clearly define what this actually means in practice. A concrete pour checklist is your ultimate defense mechanism as a site engineer. It is a strict, step-by-step site checking process used before, during, and after placement. It's exactly how you control quality, safety, documentation, and execution. Think of it as your essential QA/QC toolkit. If you have this checklist, and more importantly, if you actually use it, you completely prevent those costly rectifications we just talked about.
To understand how to execute this flawlessly, we've got to break the process down into three distinct phases. Phase 1 is before the concrete truck even arrives at the site. Listen to me carefully on this one. Preparation is where the battle is won or lost. If you wait until that RMC truck is honking at the main gate to start checking your formwork, you have already failed.
Now, what's really interesting about these pre-pour checks is how painfully basic these items are, yet they are the exact things most frequently ignored. Your pre-pour checklist has to start with the latest approved drawing. You check the member size, inserts, sleeves, the whole shebang. Then, thoroughly check the reinforcement, bar diameter, spacing, lap lengths, and shares. You absolutely must check that proper cover blocks are securely in place so the rebar doesn't get exposed later. Check the shuttering for verticality, check the supports, make sure it's tight, and apply that shuttering oil. And finally, please, look inside the formwork. Get the leftover binding wire pieces, the loose wood shavings, the dust, and the standing water out of there. Leaving debris inside literally guarantees weak spots in your final structure.
Still in phase 1, you need to verify your manpower and your equipment. Are your masons and helpers actually ready and on standby? Do you have an experienced vibrator operator?
Because let me tell you, an unskilled operator will either under-vibrate, causing massive honeycombing, or over-vibrate, causing the heavy aggregates to sink to the bottom and the water to bleed to the top. Is the QA/QC person physically present? Do you have all your necessary tools? And crucially, have you confirmed the concrete grade, the mix design, and a solid backup arrangement just in case something goes wrong at the plant?
Once everything is perfectly in order, you officially authorize the pour. This brings us to phase 2, controlling the chaos during the pour. And it is chaos. An active pour is loud, it's fast, and it can get messy. This is the exact moment where you, as the site engineer, must be the most vigilant. You absolutely cannot sit in the site office drinking chai while the pour is happening out there. You need to be right in the thick of it.
Here is your exact sequence of actions during this phase. First, before a single drop of concrete goes into that formwork, you conduct a slump test to check the workability, and you record that value immediately. Second, you actively supervise the pouring method. Avoid free fall from excessive heights at all costs. That just causes segregation. Make sure they place the concrete in uniform layers. Third, monitor the needle vibrator compaction like a hawk. And fourth, constantly watch the reinforcement. As that heavy wet concrete hits, make sure your cover blocks, chairs, and conduits aren't getting pushed around or crushed.
And hey, while you are watching the concrete, you absolutely must watch your people. Ignoring safety risks during an active pour is a massive failure of your core duties. Check that every single person is wearing proper PPE, ensure there is safe access, and a totally stable working platform for the laborers who are guiding the heavy concrete pipe. Pay super close attention to electrical safety, especially with those vibrator cables dragging through wet concrete. And if your pour is extending into the evening, proper, bright lighting is absolutely mandatory. No excuses.
All right, the trucks are empty. The concrete is finally in. You might be thinking it's time to pack up your gear and head home. But hold on. Phase 3 is after the pour, and trust me, the job isn't done yet. Walking away immediately after the concrete is placed is a critical, textbook rookie mistake. Concrete isn't just mud drying in the sun. It's a complex chemical process. It needs continuous care to actually achieve its designed structural strength.
Your final steps here are completely non-negotiable. First, check the top level, ensure proper surface finishing, and double-check those slopes if they're required. Second, immediately start the curing process. And by the way, your curing arrangement should have been planned out way before the pour even started. Third, make sure concrete cubes are cast exactly as per your quality plan. Record the cube ID, the date, the location, and the sample details. Without those cubes, you literally cannot prove the concrete's actual strength to the client later on. And fourth, log every single detail immediately.
And this brilliantly illustrates what happens when those steps are ignored. The data tells a truly brutal story. Let's break down the most common negligent mistakes that end up ruining Indian concrete pours. A staggering 35% of the time, the root issue is missing cover blocks. 25% of failures come straight from loose shuttering joints, just leaking slurry everywhere. 20% is from poor, rushed compaction with a needle vibrator. 15% from having absolutely no curing arrangement ready, leading to nasty shrinkage tracks. And 5% from having no slump record, meaning we blindly poured concrete that was either way too stiff or basically soup. Every single one of these, 100% preventable.
Let's move on and see how this builds into your daily routine. Your daily progress report, or DPR, is your shield. You must meticulously enter the concrete quantity, the exact location, attach clear photos, note the cube details, the manpower, and the machinery used. Why go through all this trouble? Because this maintains your site documentation, it ensures the contractor actually gets billed correctly, and most importantly, it protects you and your entire team from ugly client disputes. If a question arises 3 weeks from now, your detailed DPR is the undeniable proof that you did the job right.
I really want you to let this core truth sink in. A good site engineer does not approve a concrete pour by visual checking only. It is the absolute golden rule of site execution. Visual checks are just illusions. Systematic, documented checklists are reality. If you rely only on your eyes, you aren't engineering. You are just gambling with the project's structural integrity.
The crucial point to take away today is this. Your fundamental responsibility is to prevent failure. You do that by rigorously checking the approved drawings, actively managing your manpower, verifying your materials, strictly enforcing quality controls like slump tests and compaction, ensuring site safety, taking accurate measurements, maintaining bulletproof documentation, and submitting detailed daily reporting.
That, my friends, is what truly defines a professional site engineer.
If you follow this exact process, your concrete pours are going to be smooth, they'll be strong, and they will be totally defect-free. Now, if you want the exact step-by-step checklist to print out and take with you to the site, for the detailed PDF guide, take it from our Telegram channel.
Always remember, the site is your responsibility. Do the checks, follow the process, and build something you can genuinely be proud of. The Telegram link is in the YouTube description or pinned comment. If you have any doubts, comment below. IBG and I will reply. The next time you step onto a site and you hear that RMC truck roll in, just ask yourself, are you about to build a structure that will stand tall for generations, or are you just overseeing a 50 cubic meter mistake waiting to happen? Stay safe out there on the site and keep learning.